Welcome to Ganita Vahini. I am HarshaVardhana. Hello everyone. Welcome to Ganita Vahini. I am HarshaVardhana. In previous session, we solved about some of the problems on complex numbers. In today's session also, we are going to solve some more problems on the complex numbers. Here the one problem such that simplify -4 -5 +7 and +6i. To simplify this expression, we have to separate real parts and the imaginary parts. The real parts are -4, -5 and +7. The imaginary parts is +6i. Therefore, if we add -4, -5 +7 give rise to -2, then the expression simplifies to -2 plus 6i. After this problem, we move to the next problem. Simplify -4 -i +7 +6i. Here in this problem also, we have to separate real and imaginary parts. -4 and 7 are real parts. -i plus 6i are the imaginary parts. We know that I is equal to root -1. So the problem is solved by combining the real parts and the imaginary parts separately. After this, we have to add the constants together. It gives -4 plus 7 give rise to 3, and if we combine the imaginary parts, here we have to add the coefficients of the imaginary unit I. If we take I as common, we left with -1 and +6. That is, therefore, -i plus 6i give rise to -1 plus 6 into I give rise to 5i. Therefore, final expression becomes 3 plus 5i. Then we move to the next problem. Simplify -8 plus 4i minus 7. Here in this problem also we have to separate the real and the imaginary parts. The real parts are -8 and -7, and imaginary parts are 4i. After this, we add the constants together. To give -8 -7 give rise to -15, and if we add the imaginary parts, there is only one part, that is 4i. Therefore, final expression becomes -15 plus 4i. After this, we have another problem, -6 plus I plus 2 minus 6i. Here we combine the real parts, that is -6 plus 2 give rise to -4. In step 2, we combine the imaginary terms, that is I minus 6i, that is equal to -5i. After this, we combine the result from real and imaginary parts, gives the final simplified expression, that is -4 minus 5i. We have another problem such that -6i plus 2i. To simplify the expression, we combine the coefficients of the imaginary unit. If we take I as common, we left with -6 plus 2, that is give rise to -4i. Here we have one more problem such that 3 into 1 minus 2y minus of minus 4 minus 5y plus of minus 8 plus 3y. Here in step 1 we simplify the inner parenthesis. That is, first we simplify the terms within the main parenthesis, that is minus 4 minus 5y plus of minus 8 plus 3i. It becomes minus 4 minus 8 plus of minus 5y plus 3i. Give rise to minus 12 minus 2y. Then in second step we expand the expression. Here we substitute the simplified inner part back into the original expression, that is equal to 3 into 1 minus 2i minus of minus 12 minus 2i. Here we distribute in the first part and negative sign in the second part. That is 3 into 1 minus 3 into 2i. Minus of minus is plus 12. Minus of minus is plus 2i. Give rise to 3 minus 6i plus 12 plus 2i. In this step, we group the real and imaginary terms. Give rise to 3 plus 12 plus of minus 6 plus 2i. And this here we performed addition. The answer give rise to 15 minus 4i. Here the one more problem such that 1 plus I into y square plus 6 plus I is equal to 2 plus I into x. The answer such that 1 plus I into y square plus 6 plus I is equal to 2 plus I into x. Y square plus iy square plus 6 plus I is equal to 2x plus ix. Y square plus 6 plus I into y square plus 1 is equal to 2x plus ix. Here we combine the real and imaginary parts. In real we get y square plus 6 is equal to 2x. If we compare imaginary parts, y square plus 1 is equal to x. That implies y square is equal to x minus 1. Putting the value of y square in 1, we get x minus 1 plus 6 is equal to 2x. That implies x is equal to 5. Therefore, y square is equal to 5 minus 1, that is equal to 4. Y is equal to plus or minus 2. Therefore, x is equal to 5 and y is equal to plus or minus 2. Here we find the another problem such that find the sum and the product of complex numbers minus root 3 plus root minus 2 and 2 root 3 minus I. In step 1 we rewrite the complex number. The first complex number is minus root 3 plus root minus 2. So we can express minus root 2 in terms of I, that is imaginary unit. That is root of minus 2 can be written as root 2 into I. Thus the first complex number can be rewritten as minus root 3 plus root 2I. The second complex number is already in the standard form, that is 2 root 3 minus I. In second step we have identified the complex numbers. Let z1 is equal to minus root 3 plus root 2I and second complex number z2 is equal to 2 root 3 minus I. After second step we move to the step 3. Here we calculate the sum. In this we have to find the sum z1 plus z2. z1 plus z2 is equal to minus root 3 plus root 2I plus 2 root 3 minus I. Combining the real and imaginary parts, we get minus root 3 plus 2 root 3 plus root 2I minus I. Finally, we get the answer root 3 plus root 2 minus 1 into I. After that, we calculate the product. Here we find the product of z1 and z2. z1 into z2 is equal to minus root 3 plus root 2I into 2 root 3 minus I. Here we use the distributive property using FOIL method. Minus root 3 into 2 root 3 plus of minus root 3 into minus I plus of root 2I into 2 root 3 plus root 2I into minus I. After this, we calculate the each term. Minus root 3 into 2 root 3 is minus 2 into 3, that is minus 6. In second, we have minus root 3 into minus I give rise to root 3I. After this, we have root 2I into 2 root 3 is equal to 2 root 6I. Then root 2I into minus I is equal to minus root 2 into minus 1, that is equal to root 2. Now combine all the terms, we get minus 6 plus root 2 plus root 3 plus 2 root 6 into I. Therefore, thus the sum and the product of the complex numbers are as follows. Sum is equal to root 3 plus root 2 minus 1 into I, and product becomes minus 6 plus root 2 plus root 3 plus 2 root 6 into I. This finishes the problem, and that's all for this session. Those who have any doubt or clarification in this session or in this videos, put a comment in the comment box. I will rectify the same. And those who didn't witness the video, I put the link in my description box. You can click on the link and see our videos.